A very good morning, students. So now let's begin the revision of our lesson number 3, force and pressure, which is also included in our first unit test examination. So we are going to revise this chapter today. Let's begin with question number 1, that is write proper word in the blank space, that is of fill in the blanks type. So the first one, the SI unit of force is dash. So students, we have learned the international system unit. So the SI unit of force is Newton. Correct answer is Newton. Second one, the air pressure on a body is equal to the dash pressure. So the air pressure on a body is equal to the atmospheric pressure. Third one, for a given object, the beyond force in liquids of different dash is the same. So when we were learning beyond force, we have learned the force in liquids of different density is the same. Fourth one, the SI unit of pressure is dash. So what is the SI unit of pressure? It is Newton per meter square. Why it is Newton per meter square? Because the formula for pressure is force upon area, and force is given by Newton and area is meter square. So the SI unit of pressure becomes Newton per meter square. Question number 2, make a match. We have to match the correct pair. In the A group, the first one, fluid. So what is the correct match? Find it in the B group. So the correct answer for fluid is same pressure in all directions. We have learned fluid exerts same pressure in all the directions. Second one, blunt knife, and the answer for blunt knife is lower pressure. Blunt object exerts low pressure. Third one, sharp needle. Sharp needle, the blunt object exerts lower pressure. So when there is a sharp object, it's going to exert higher pressure. So the correct match for sharp needle is higher pressure. Fourth, relative density. Answer for relative density is specific gravity, because we have studied relative density of a substance is called its specific gravity. So the correct match for relative density is specific gravity. Next one, hectopascal. What's the answer for hectopascal? It's the unit given for atmospheric pressure. So the correct answer is atmospheric pressure for hectopascal. Question number 3. Answer the following questions in brief. What is the first question? Let's see. Why do the load carrying heavy vehicles have large number of wheels? So students, those vehicles which carry load have large number of wheels. Why is it so? And the answer is, the pressure produced by a given force depends on the area of the surface on which the force acts. The greater the surface area, the less is the pressure produced. Load carrying heavy vehicles have large number of wheels so that the load, that is the weight, is distributed over large surface area of the wheels in contact with the road. Hence, the pressure decreases and the tires do not burst. So students, why the load carrying heavy vehicles have large number of wheels? Because the pressure produced by a force depends on the area of the surface. So if the vehicles of load carrying have large wheels, then what would happen? If we are increasing the surface area, the less will be the pressure produced. So that's why to reduce the pressure, vehicles have large number of wheels. So the greater the surface area, the less is the pressure produced, and so that the pressure decreases and the tires do not burst. This is the reason the load carrying heavy vehicles have large number of wheels to decrease the pressure. Next question, how much pressure do we carry on our heads? Why don't we feel it? Have you ever think of it? How much pressure do we carry on our head but we cannot feel it? Because the air pressure at the sea level is about 101 multiplied by 10 raised to 3 Pascal. This is the pressure that we carry on our heads. The cavities in our body are filled with air and arteries and veins are filled with blood. Their pressure balances the pressure due to the atmospheric. Hence, we don't feel the atmospheric pressure. So, students, because of the atmospheric pressure created, we cannot feel the pressure which we carry on our head, because the air pressure at the sea level is about 101 multiplied by 10 raised to 3 Pascal. This is the pressure that we carry on our head. And in our body, the cavities are filled with air and arteries and veins are filled with blood. Their pressure balances the pressure due to the atmosphere. So, there is the balance between both of them. Hence, we do not feel the atmospheric pressure. So, as we cannot feel the atmospheric pressure, we cannot feel the loads or the pressure that we carry on our heads. Question number 4. Why does it happen? Fruits can easily be cut with a sharp knife. Why we can cut easily the fruits with a sharp knife than a blunt knife? Because the effect of a given force varies inversely as the area of the surface on which the force is applied. The less the surface area, the greater is the effect of the force. So, the cutting edge of a sharp knife has less cross-sectional area relative to that of a blunt knife. Hence, it is easy to cut vegetables, fruits with a sharp knife rather than with a blunt knife. So, students, the effect of a given force varies inversely as the area of the surface on which the force is applied. If there is less surface area, greater is the force. So, the cutting edge of a sharp knife has less cross-sectional area. So, due to the less cross-sectional area, it applies greater force on the vegetables and fruits. So, it is easy to cut vegetables with a sharp knife rather than with a blunt knife. Next question. The wall of a dam is broad at its base. Why the wall of a dam is broad at its base? Because the pressure at a point in a liquid is proportional to the height of the liquid column above it. Hence, the pressure of water in a dam is much greater at the bottom of the dam than at the top. To withstand this higher pressure, the wall of a dam is made stronger and thicker, that is, it is made broad at the base than at the top. So, students, the pressure of water in a dam is greater at the bottom level, at the bottom of the dam. So, the higher pressure, the wall of dam is made stronger. So, where there is higher pressure of water, at that place the wall of a dam is made stronger and thicker, that is, it is made broad. For what reason? To withstand this higher pressure, to face this higher pressure. So, the wall of dam is broad at its base. Next question, why does it happen? If a stationary bus suddenly speeds up, passengers are thrown in the backward direction. Why did it happen, students? Have you ever felt it? If a stationary bus suddenly speeds up, the passengers are thrown in the backward direction. It's because when passengers sit or stand in a stationary bus, they are in a state of rest. When the bus suddenly speeds up, the lower parts of their body in contact with the bus acquire the speed of the bus. The upper parts of their body, however, continue to be in the state of rest. due to inertia. Hence, they are thrown in the backward direction. So, why it happens? When the bus is when passengers sit or stand in a stationary bus, they are in state of rest. They are not in any of the motion. So, when the bus suddenly speeds up, the lower parts of their body is in contact with the bus that acquires speed, and the upper parts of their body, however, continue to be in the state of rest. The upper parts of their body are in rest position, but the lower parts of their body are in contact with the bus. So, as soon as the bus acquires the speed, they are thrown in the backward direction. This is all due to inertia. Now, let's revise the numericals which we have solved in this lesson. The first one, the area of the bottom of a tiffin box is 0.25 meter square and weight is 50 N, where N stands for Newton. Calculate the pressure exerted by the box on the shelf. So, students, here we have to calculate the pressure. First, write the given things. Area is given as 0.25 meter square. Weight of the box is given as 50 N, that is Newton. What to find? Pressure. So, pressure is equals to question mark. Solution. First, write the formula. We know when we have to calculate pressure, pressure is equals to force upon area. So, pressure is given as force upon area, and force is 50 N divided by area, and area is given as 0.25 meter square. Now, here is mathematical calculation. When we have to shift the decimal point, when we have to remove the decimal point from the denominator, we have to add zeros in the numerator. So, the decimal point is before 2 digits. So, to remove that decimal point, we have to first add 2 zeros in the numerator's place. So, it becomes at 5000 upon 25. Now, when we calculate, we have to divide. So, 25 ones are 25, 25 twos are 50, and what remains? 20 remains, which is as it is. So, what is our answer? It is 200. So, pressure is equals to 200, and what's the unit of pressure? It is Newton per meter square. So, pressure is equals to 200 Newton per meter square. Pressure exerted by the box on this shelf is equals to 200 Newton per meter square. Numerical number 2. Calculate the relative density of iron if the density of water is 10 raised to 3 kg per meter cube and the density of iron is 7.85 multiplied by 10 raised to 3 kg per meter cube. So, students, in this we have to find the relative density of the substance, and the substance given here is iron. So, first write all the given things. What are the given things? They are density of water, which is given as 10 raised to 3 kg per meter cube. Then second given is density of iron, which is 7.85 multiplied by 10 raised to 3 kg per meter cube. Now, to find, what to find? Relative density of iron is equals to question mark. Solution. In solution, our first step, we have to write the formula. Relative density is equals to density of substance divided by density of water. So, as our substance given is iron, so relative density of iron is equals to density of iron divided by density of water. Now, substitute the value. Density of iron 7.85 multiplied by 10 raised to 3 kg per meter cube divided by density of water, which is given as 10 raised to 3 kg per meter cube. Now, do the calculation mathematically. Mathematically, 10 raised to 3 kg per meter cube in the denominator is same as in the numerator. So, both gets cancelled from the numerator also and in the denominator also. So, what remains? 7.85. So, the final answer is relative density of iron is 7.85. And students, we know relative density does not have any unit because both are measured in physical quantity. So, the units gets cancelled. So, the relative density doesn't have any unit. So, our final answer comes as relative density of iron is equals to 7.85. So, students, we have revised all the objectives, all the answers and all the numericals from lesson number 3, force and pressure. Watch the video attentively. This will help you to solve your first unit test paper. Thank you so much, students, for your attention. Have a beautiful day.